All right. So the next topic that we're going to be covering is chord secants and tangents, which is part one. So first off, starting with the definition, a chord is a segment whose endpoints lie on a circle. Okay. So if you notice here, A, B, and C, D are considered chords. Okay. It's just the parts that's lying on the circle, not the parts outside. Okay. A secant is a line that intersects a circle at 2 points. So it's going to intersect, but it's going to continue on out in both directions. Okay, so CD is considered a secant because it does go through 2 points. The keyword here is 2 points. Okay. A tangent, on the other hand, is a line that's on the same plane as a circle and intersects the circle at exactly 1 point. This point is called the point of tangency. Okay, so for example here, this is a tangent line because it only touches at 1 point, and E is a point of tangency. Okay, so let's see. Here it says identify each line or segment that intersects the circle. Oh, radii and diameters also intersect circles. I forgot to read that part. So FG. So from F to G, this is considered our diameter of our circle. Now it is considered a chord as well, but because it is a special type of chord, it's called a diameter. Okay. HG, also from H to G, is going to be our radius. Okay, radii is a plural way how to say radius. Okay, it means more than one. Then we have line L. So line L, this is going to be considered line L. Here's line L. This is going to be considered a secant because it does cross at 2 points and it continues outside. Okay, so this is a secant. And then M. M is going to be considered a tangent line because it only crosses at 1 point, and that's the point of tangency. So tangent. Okay. And then from there, let's see, the next part we have is LM. So LM is considered to be a secant line. Secant, because it does cross at 2 points and it doesn't stay just inside the circle. It has a little line, so it's talking about the whole thing, including the arrows. Okay, here the next one says KJ. Now KJ goes from the endpoint of a circle to the center of the circle, which is considered a radius. Okay, the next one is MN. Now MN is considered a tangent of the circle because it does cross only at 1 point, or I mean it only touches the circle at 1 point, which is its point of tangency at M. So this is considered a tangent line. And then we have LM. Now, LM is going to be considered a chord. So do you see how it doesn't have the arrows on top of it? So it's only talking about the section that's within the point L and M, not the part beyond. So because it's just that little section there, that is considered a chord. All right, next, it says congruent arcs, chords, and central angles. So if the measure of angle BEA is congruent to the measure of angle CED. So pretty much what this is saying is that if these two angles in here are congruent, then we can say that BA and CD are also congruent. So we can say that these lines here are also congruent. Okay, they even put little tally marks here to show us that they're the same. Now the opposite, or not the opposite, but here it says if you have the measure of BA and CD, so if they tell you that the chords are the same, then we can automatically assume that the arcs are also the same. So these arcs would be equal in measure. That's what this one says. And lastly, it's saying that if you have these two angles, these two arcs, which is BA and CD, if the arcs are the same, then we can automatically assume that these angles in here are the same. Okay. So the next part, find each measure. So here it tells us that QR is congruent to ST. So with this information, that means that these arcs are also the same. So I'm going to set it up 4x equals 3x plus 22. And we start solving for x. So I'm going to subtract the 3x first. Okay, this cancels. 3x minus 4x is just x. And that gives us 22. They don't want us to find x. They're trying to get us to find the measure of QR, which is here. So all I got to do is plug it in here. So 3 times 22 is 66 plus another 22. Gives us 88. So the measure of QR, our QR, is equal to 88 degrees. All right, the next one. So here they do tell us that the measure of HLG is congruent to KLJ. And so they do put the little arc marks here to show us that they're congruent. They want us to find the measure from G to H, so right here. So if those angles are congruent, then HG and JK are also congruent. So I'm going to set this up 2y plus 5 equals y plus 13. And we're going to start solving for y, so I'm going to move over the y first. So 2y minus y just gives me 1y plus 5 equals 13. 5, I'm going to move that over by subtracting, and we get y equals 13 minus 5 is 8. Now we're not done yet because they're not asking us to find y, they're asking us to find gh. So I'm going to go ahead and plug it in here. So 2 times 8 is 16 plus 5 gives us 21. So gh is equal to 21. Hello?
Hi, this is Kipper with Quality.
Yes.
Okay, so I got all of those rooms adjusted. I need your email. I actually did not write it down yesterday, or I wrote it on the paper day early.
Okay, that's fine. It is CMARRUFO 4 at YISD.net.
Alright, and I'll start sending these right over to you.
Alrighty, thank you so much.
You're welcome.
Bye-bye. Okay, I'm sorry about that, guys. It was an important call. All right, so GH is equal to 21. So now moving on to the next one. In a circle, if a radius or diameter is perpendicular to a chord, then it bisects the chord and its arc. So what does bisect mean? Well, bisect means that it cuts into 2 equal parts. So then that means that from C to D is going to be, C to the center is going to be the same as D to the center. They didn't give us a line, but these 2 little sections are the same. Okay. Now, not only does it bisect it, okay, it also makes this right angle in here. So here it says find each length to the nearest tenth. So they want us to find from N to P. Okay, so first off, if we look at this, from L to M, it is 6 and 4 together. That's going to give us the whole radius here is going to give us 10. Okay. Now, I am going to make a radius here from L to P. We know this is 10, okay, because the radius is 10. We just figured that out from right here because we added 6 plus 4. I'm going to go ahead and erase this so it doesn't get super messy. But if you notice here, we have this right triangle, this little section here. So I'm going to call this little piece X, and we can find X by doing A squared plus B squared equals C squared. So 6 squared plus X squared equals 10 squared. 6 squared is 36, plus X squared equals 100. I move the 36 to the other side. This gives us X squared equals 64. I take the square root, and for X we get 8. So that means that from here to here is 8, and because this is bisecting this line, that means this other side is also 8. So from N to P is going to be equal to 16, because 8 plus 8 is 16. The next one, we're going to do the exact same thing just in case you're still a little lost. So from H to F, we're going to make this line right here. H to F is a radius. Now our radius should be the same as from here to here. So 8 plus 9 is 17. So that means that this is 17. Let me erase that. So now we have this right triangle going on right here. Okay, this is my right angle. So this is A squared plus B squared equals C squared. Okay. So I'm going to call this X, so we're going to do 8 squared plus X squared equals 17 squared. I know 8 squared is 64, 17 squared I don't know off the top of my head. I'll go ahead and plug it into my calculator. And that gives me 289. I'm going to go ahead and move over the 64 to the other side. And we get X squared equals 289 minus 64 gives me 225. I take the square root, and the square root of 225 is 15. So that means from here to here is equal to 15. But they're asking us for the whole thing from E to F. So then that means this is 15 also. So that makes the whole thing equal to 30. All right, so the next part is if 2 segments are tangent to a circle from the same external point, then the segments are congruent. So if you have two tangent lines and they meet out here at this outside point, they are going to be the exact same measure. They're going to be equal. Okay, so that's what this says. So here it says the segment in each figure are tangent to the circle. Find each length. Okay, so because these are two tangent lines and they meet out at point K, they're going to be equal. So I'm going to set it up 2x plus 5 equals 3x minus 2. Okay, so I'm going to go ahead and subtract the 2x and move it to the other side. And we get 5 equals x minus 2. Then I move the 2. 5 plus 2 gives me 7. That's going to equal my x. Now they're not asking us for x, they're asking us for jk. Okay, so jk equals, I'm going to take the 7 that I got for x and I'm going to plug it in. So 2 times 7 is 14 plus 5 gives me 19. Okay, if you want to double check your work, plug it into the other one. It should give you the same number. So 3 times 7 is 21 and 21 minus 2 is 19. And the last one, so we're looking from L to M. Now because these are two tangent lines, we're going to set them equal to each other. So 2y minus 2 equals y plus 6. They should be the exact same size. So I'm going to start solving for y. I'm going to subtract the y first. So 2y minus y is just going to give me 1y minus 2 equals 6. I move the 2, so I add it, and I get y equals 6 plus 2 is 8. Okay, so since y equals 8, I'm going to go ahead and plug it in here for LM. So 2 times 8 is 16 minus 2 gives me 14. So LM is 14. Now if I did this right, of course I can check my work again. 8 plus 6 is 14. So I did do this correct. And that's it. Thank you guys. Bye.